Good morning, grade 8. Today we are going to start a new chapter, chapter 7, about magnetism. What is magnetism? Magnetism means I use magnet. Yes? What is magnet? Magnet is any material that attracts iron. A magnet is any material that attracts iron, and the materials that contain iron. So the magnet can attract any material made of iron or contain iron. So magnet is a rock or stone found naturally, okay, and they've discovered the properties of this magnet. They found that any material made of iron attracted to this rock or this magnet, and this rock discovered in magnesia. Yes, this is a country called Magnesia, and they called this rock by the magnesia and called magnet. They found that magnets attract or repel other magnets, can attract magnet and they can repel other magnets. So the magnet with a different area, two different area, yes, later on named them poles, two different poles, north and south poles. So we have three properties for a magnet. Three properties for a magnet, any magnet. Number one, magnets attract iron and materials that contain iron. Number two, magnets attract or repel other magnets. Magnets attract or repel other magnets. Number three, magnets have north and south poles, always point north when suspended freely, when allowed to swing freely, and suspend it through a string and swing it freely, it will point to north. This is natural. Yes? So, what is magnetism? Attraction or repulsion of magnetic materials. The attraction or repulsion, this is called magnetism. How do magnetic poles interact? How do magnetic poles interact? Number one, we have law for magnets. Magnetic poles that are unlike attract each other. Unlike means different. And the magnetic poles that are alike means similar. Alike repel each other. So unlike magnet attract, like magnet repel. This is law of magnets. Or like poles repel and the unlike poles attract. Like poles repel and the unlike poles attract. This is law of magnets. And they found the magnetic effect of magnet is strongest at the poles or at the tip of the magnet. This is strongest area for 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 magnet. So the magnetic effect of magnet strong or stronger than in the middle. The magnetic effect of the magnet at the two poles stronger than at the middle, or strongest at the poles. The magnetic effect of the magnet is strongest at the poles. Okay, and like magnet or like poles of magnet repel. Like poles of magnet repel, so north, beside north, they repel each other. South, beside south, repel each other. But north and south, they will attract. South and north, they will attract. Okay? So, like poles repel and the unlike poles attract. What about magnetic force? Magnetic force is the attraction or repulsion between magnetic poles. This is called magnetic force. Two poles together, whatever, like or unlike, the attraction or repulsion happen. This is called the magnetic force. Magnetic force means the force of the magnet that attracts other magnet or that repel other magnet. This is called magnetic force. The force of a magnet that can attract other magnet. This is magnetic force. Or can repel other magnet. This is magnetic force. So, force of push or a pull that can cause object to move. This is magnetic force. I can push, so I make difference. The magnet moved to the other magnet when it pushed to it. This is attraction. When the magnets repel each other, so the other magnet will move away from the magnet. So this is movement. This is repulsion force, yes? So repulsion or attraction, push or pull. What is a magnetic field shape? What's meant by magnetic field? Magnetic field area. Area around the magnet. The area of magnetic force around the magnet. When you imagine together about the area around the magnet, look at the two north and south poles of the magnet. If you scatter some iron filing, they found these iron filing make shape like this around the magnet. Look, this is magnetic field. This is imaginary area. Yes, this is imaginary lines, or the lines are imaginary, but it appears when you scatter iron filing. Yes, but itself, without iron filing, we cannot see the magnetic field, but the magnetic field present around the magnet, yes, and the lines in and out from the poles of the magnet are drawn like this, yes. The area of magnetic force around the magnet, this is magnetic field, because magnetic fields magnet interact means attraction or repulsion. This is the interaction of the magnet, means attraction when push or pull. This is attraction or repulsion, push or pull. Okay. The magnetic field lines. They found these magnetic field lines never cross or never intersect, never overlap with other. Yes? So the magnetic field lines spread out from one pole, yes, curve around magnet, and return to the other pole. Yes, it comes from north, moved way out toward south. So out from north and move toward south. Spread out from one pole, curve around the magnet, and return to the other pole. This line, or these lines, never cross like this. Where is the strongest point of magnetic field? Strongest where? At the two poles, as I mentioned before. What is the weakest field? Away from the poles, so at the center. The weakest. So look at the sprinkled iron filing. These iron filing concentrated at the poles. But weakened. They are weakened at the center. Yes. The lines always leaves north and enter south. The lines leave the north and move toward south or enter south. Look at different magnetic field. We have single magnetic field and we have combined magnetic field. Single magnetic field, magnetic field around single bar magnet. Look at this bar magnet vertically or perpendicular. Look at the lines out. If north, so it will out. If south, it will move toward it or enter it. This is, I think, south, because look at the direction of the iron filing. Look, enter, move toward. What about the iron filing that's scattered around bar magnet? Look at the arrangement of iron filing. Amazing. Never intersect. Yes, concentrated at the two balls and gets weaker at the center. Yes, yes, look. And also look at horseshoe magnet. Horseshoe magnet, the iron filer concentrated at the two balls, north and south, and make a magnetic field area. What about this area? This is the middle. No arrangement happen. Why? Because the magnetic field gets weaker as you move away from the two balls. Gets weaker as you go away from the two balls. Okay. What about combined magnetic field? Two magnetic fields may be different like this or may be similar like this. Look at the areas that formed the magnetic field. Look at when two balls of two bar magnets are brought near each other, north-south or south-north. Look at the arrangement. They attract each other, and the iron filing fill the area between north and south. Look at the curve out from north, go toward the south, and so on. But what about north and north or south and south? Empty area in between. Yes, empty area. Because both of them out, the magnetic field move away from this ball and move away. So it make curves out like this and form empty area in between them. What about Earth's magnetic field? Earth has magnetic field, yes. Why, miss? Because the region of Earth, we have a lot of regions. We have crust layer, and we have mantle layer, and we have core. The core of Earth, we have outer core and the inner core. The outer core of a magnet is made of what? Molten or liquid iron. We have iron inside the outer core of the Earth. This is iron, is liquid, hot liquid, yes, and this hot liquid iron creates magnetic field because the iron, the liquid hot iron, swirling يعني swirling, okay, swim or move. This movement make magnetic field or creates a magnetic field. So Earth's magnetic field, just like a bar magnet, Earth has magnetic field around it and two magnetic poles. So we have two magnetic poles for our Earth. Earth's core is a large sphere of metal, mainly iron. The outer core is made of hot swirling liquid iron. The motion of this iron creates a magnetic field, yes, similar to magnetic field of bar magnet. Look at your book. Open page 202 and 203. Look at the magnetic field, yes, the magnetic field. Firstly, in page 202, we have bar magnet, north-south. I can draw the magnetic field exactly like above picture, and north with north. We can draw also the magnetic field like this one, like above picture, and also south and north. We can make this is combined magnetic field area full of sprinkled or iron filing spreading between south and north. Look, so no empty area formed between them, and the magnetic field never cross together. Yes. And ask me about if you have a magnet, refrigerator magnet. A refrigerator magnet can attracted on the refrigerator and also create magnetic field. Yes, due to created of magnetic force. Okay. In assessment page 203, what is a magnetic field? Magnetic field, the area of magnetic force that surround a magnet. And ask me in question number B, describe the magnetic field of a south-south pole exactly the same as NN. South-south like NN in page 202. Yes. Move to page 204. Identify the main idea. What is the main idea in the Earth's core section? Core section made of liquid iron, hot liquid iron, and hot liquid iron swirl or move through Earth. This creates a magnetic field. The motion of liquid iron in the Earth's core creates a magnetic field similar to a bar magnet. Similar to a bar magnet. Yes. Question Earth's magnetic field in page 204 also. Why might compass not work correctly when it's near strong magnet? Compass by this needle, this is needle used to determine the direction. Yes, the needle will align if you put it beside a strong magnet. What happens? A strong magnetic field will affect the movement or the free motion of the needle of the compass. So the needle will align with the magnetic field of the magnet, of the strong magnet. It's near it because this closer or this motion, movement beside beside each other, so much closer to the magnet, this affects the magnetic field of the compass. Yes, much closer of compass beside strong magnet affect the magnetic field, so it cannot will not work correctly. Okay, in page 205, Earth has a magnetic field. Why? Due to motion of a liquid iron in Earth's core. Due to motion of liquid iron in Earth's core. Okay, thank you all of you.